some dimensional analysis practice here on this beautiful 7th of September. And what we have is from the practice problems, square root of v over 2a delta x equals initial velocity, vi. So to do dimensional analysis, of course, what we want to do is put in units in place of all those variables. So we know that velocity is given in what? Meters per second. And though I tend to write fractional things like that and units like that, when I'm writing them and I'm doing algebra with them, I'm really careful to write them dead level because and this is me, but I tend to screw up my algebra more if I don't do that because it slips my mind that that's division. And I saw some of you do that on the factor labels yesterday. Like, I don't register that that's actually division and that would be 1 over 1 under if I make a slanted line. It sounds stupid, but hey, you know what? I've learned where most of the, not all, but a lot of the potholes are. So now I kind of know how to avoid them. So meters per second let's switch back to black. Divided by, well, I've got 2, which we're going to get rid of. Acceleration, what units is acceleration in? Meters per second squared. And then I've got that times delta x, change in position, which is going to be in what? Meters. And this whole thing, so sometimes I do that to remind myself I'm multiplying that times the entire fraction on the bottom. That whole thing is equal to velocity, which is going to be in what units? Meters per second. Okay. I'm going to shrink this up a little bit. Okay, so I can get rid of the 2 because it's not a unit, and we're going to ignore anything that's not a unit for the purposes of dimensional analysis. We're just checking to see if the units work. So I'm going to first, how many of you were able to get to here on this? Okay. So first I'm going to basically get everything into a fraction. Usually we're so concentrating on getting things out, getting things rationalized. But here I have to multiply that meters on the bottom across. So I'm going to have meters per second over meters squared over seconds squared. And I can extend to make sure it's clear that that's the entire thing. So meters per second, square root of meters per second divided by meters per second squared, meters squared over seconds squared equals meters per second. That's what we have so far. Well, this side of the equation is already pretty simple. We don't need to do anything with it. But we've got a lot of work to do to get the other side of the equation as simplified as we can. So this is something that you will do frequently in here, and it's an algebra skill that it's one of the most common pitfalls. Dividing by a fraction, what do you actually do? Invert and multiply. Invert and multiply. Invert and multiply. So I'm gonna do sort of a side bubble here. Meters per second times seconds squared over meters squared would actually be what that looks like. So that gives us meters seconds squared over meters squared seconds. What a pain in the tuchus. What can I get out of your way up here? Because I see that things are in ways. Is that better? I can't remove anybody's head for you, however. So you'll just have to work that out with your friends. Okay. So going back to sort of our main stage here, we have the square root of meters seconds squared over meters squared seconds equals meters per second. Is there hope? Okay. So we still think there might be hope. Well, let's cancel out what we can cancel out over here, because that would be our next logical step. So if we're going to cancel things, well, meters cancels and the square on that meters cancel. Seconds cancel and the square there cancels. Do you see how that works? If you look back to here, it might be easier. So meters divided by meters squared gives you 1 over meters. Seconds squared divided by seconds gives you just seconds. That logical? You follow the logic there. Yes? No? Twitch, twitch, twitch. Yes, okay. Trying to read your nonverbals. Okay, so now we're down to this. The square root of seconds over meters equals meters per second. Can we go anywhere with this? You could square both sides. If you square both sides, you get seconds over meters equals meters squared over seconds squared. Is this dimensionally correct? No. It's nonsense. They're not equal. So this is not dimensionally true. So we've established that this is not a correct formula. Now let's mention one other thing about dimensional analysis. So yeah, it doesn't prove it's correct. It only says it may be. I'm going to share with you. This is one of my favorite web comics. It's called XKCD, and it's a web comic about math, science, romance, and sarcasm. I like these people. My hobby, abusing dimensional analysis. Planck energy divided by pressure at the Earth's core times Prius combined EPA gas mileage divided by the minimum width of the English Channel equals pi. Well, it's corrected with an experimental error and the units check out. It must be a fundamental law. But what if they build a better Prius? Then England will drift out to sea. Just because the units check out doesn't make it true. It's not proof. Okay, that's okay. You don't have to think it's funny. I'll just keep feeding them to you until you start laughing. So, dimensional analysis doesn't prove that it's true, but it can disprove that an expression is correct. As we get into hairier and hairier algebra, in Chapter 4, the algebra gets pretty, Chapter 3, the algebra gets pretty insane. And, I mean, it's heavy-duty Algebra 2, lots of substitutions, lots of complicated solves. We use dimensional analysis a lot to go, did I screw something up there algebraically? Do I have a problem with my algebra? And it's a good tool for you to use to check. Do you now want to just work on your practice sheets / homework for a little bit? And I can float? Okay, we'll do that.